So, hello everyone, I'm Chini Barunday, and today we're going to talk about the performance enhancements or the computer processor architectures and performance optimization techniques. So, here are the six questions that I need to answer. So, now let's start for the first question. Describe superscalar architectures and their advantages. So, superscalar architecture is a type of computer processor design that allows the execution of multiple instructions simultaneously. So, unlike scalar processors, which execute instructions one at a time in sequential order, superscalar processors can analyze incoming instructions and identify opportunities to execute multiple instructions concurrently. So think of a superscalar architecture like a busy chef in a big kitchen with multiple stoves and assistants. Instead of cooking one dish at a time, this chef can cook several dishes simultaneously, each on its own stove with the help of the assistants. So, similarly, in a superscalar architecture, a computer processor can work on multiple instructions at the same time. Just like the chef working on a multiple dishes, it can execute several instructions in parallel rather than going through them one by one. So this makes the processor faster and more efficient because it can do more work in the same amount of time. So the advantages, superscalar processors achieve this parallel execution by having multiple execution units like the mini workers in the kitchen inside the processor. These units can work on different instructions independently, speeding up overall performance. So, the main advantage of superscalar architectures is speed. By working on multiple instructions at once, the processor can complete tasks more quickly, which means programs run faster and you get results faster. It's like having a chef who can prepare a whole meal in the time it takes others to cook just one dish. So, superscalar architecture allows computers to be more efficient by doing more tasks at once, making them faster and more powerful. So, that is superscalar architectures and its advantages. Next, explain the concept of branch prediction and its utility. When we say branch prediction, it is a technique used in computer processors to guess the direction of branches or decisions in the code before they are actually determined. In computer programming, branches occur when the program needs to make a decision, such as with an if statement. So, by predicting the likely outcome of branches, the processor can start executing the instructions along the predicted path rather before it's confirmed. So an example of this is like imagine you're reading a book and there's a choice at the end of a chapter. So there is an if statement. So if the hero goes left, turn to page 50. If the hero goes right, turn to page 70. So that is branch prediction. It is like trying to guess which page you'll turn to before you actually do it. So the utility of branch prediction lies in speeding up the execution of programs. By predicting the most likely outcome of a branch, the processor can start working on the instructions along that path before it is confirmed. If the prediction is correct, great. It saves time because the processor has already started working. If not, it just discards the incorrect work and starts over, which is still often faster than waiting to know the correct path before starting any work. So, overall, branch prediction helps make computers run faster by reducing the time they spend waiting for decisions to be made. Moving on. The third question is characterize the cost and benefits of prefetching. Prefetching is a technique used in computer systems to anticipate what data or instructions will be needed next and fetch them from memory before they are actually requested. It's like getting things ready in advance based on the assumption of what will be needed soon. So think of prefetching like picking ahead in a book before you actually reach the page. The idea is to anticipate what's coming next and get it ready in advance. So this can be beneficial because when you finally reach that page, it's already there saving you time. Now, the good part, prefetching can speed things up by fetching data or instructions from memory before they are actually needed. This can help reduce waiting time and make programs run faster, similar to having things ready in advance so you don't have to wait when you need them. But there's a catch. Sometimes prefetching can fetch things that are not actually needed, wasting time and resources. It's like looking ahead in the book but guessing wrong about which page you'll turn to next. Then you've spent time preparing something you don't end up using. So in computer systems, prefetching can help speed up operations by reducing the time it takes. As what I've said, to access data or instructions from memory. And while prefetching can be helpful in speeding up tasks, it also comes with the risk of fetching unnecessary things, which can add extra work and slow things down. And it's a bit like a gamble. You're betting that the things you prefetch will be needed soon, but sometimes, you guess wrong. So that is the cost and benefits of prefetching. Fourth, explain speculative execution and identify the conditions that justify it. So, speculative execution is a technique used by computer processors to improve performance by predicting and executing instructions ahead of time. Even before it's certain they will be needed, it's like guessing what's going to happen next in a story and preparing for it before you reach that part. So, it's like taking a guess and starting to work on something before you're sure it's needed. Imagine like you're planning a party, a birthday party, and you start setting up decorations before you know for sure if everyone will show up. You're speculating that they will, so you start getting things ready. No. So in computer terms, speculative execution is when the processor starts working on the instructions before it's certain they'll be needed. It's like the processor is guessing what the program will do next and starting to work on it early. This can help speed things up because if the guess turns out to be right, the processor has already done some of the work. So here's another example. So when the processor encounters a branch in the code, like an if statement, where the program could go down different paths depending on certain conditions, it might make an educated guess about which path is most likely to be taken. Then it starts executing instructions along that path before it's confirmed whether that's the right one. So if the guess turns out to be correct, then great, the processor has already done some of the work, saving time, but if it's wrong, the processor just discards the incorrect work and starts over, which is often still faster than waiting to know the correct path before starting any work at all. So, speculative execution helps improve performance by keeping the processor busy and making educated guesses about what will happen next in the program. So, that's it. Next, discuss the performance advantages that multi-threading offered in an architecture, along with the factors that make it difficult to derive maximum benefits from this approach. So, multi-threading is like having multiple workers or multiple threads like in the kitchen, each working on a different task at the same time. So in computer terms, it means splitting a program into smaller parts, so which we call the threads. that can run concurrently. So the main advantage of this approach is speed. So tasks can get done faster because they are being worked on simultaneously. It's like having different chefs working on separate parts of a big meal. At the same time, it speeds things up because tasks get done concurrently. So here's how it helps. With speed, multi-threading tasks in a program can run simultaneously, making things faster. It's like having more people working together to get a job done quicker. Second is efficiency. Instead of waiting for one task to finish before starting another, multi-threading lets different tasks overlap. It's like chopping vegetables while the water boils, so you're making progress on multiple fronts. Third, responsiveness. Multi-threading keeps a program responsive even when handling multiple tasks. If one thread gets stuck, like waiting for data, other threads can keep chugging along, ensuring smooth performance. So while multi-threading can make things faster, it's not always straightforward to get the maximum benefit. Imagine the workers in the kitchen getting in each other's way or needing to wait for each other to finish before they can move forward. No. Similarly, in a computer, there are factors that can slow down or complicate multi-threading. First is resource sharing. Sometimes threads need to share resources like memory or data. If they are not careful, they can end up waiting for each other, which slows things down. Second, synchronization. So threads may need to wait for each other to finish their task or reach a certain point before they can proceed. So if this isn't managed well, it can create delays and bottlenecks. Okay. Third, overhead. There's some extra work involved in managing multiple threads, like keeping track of them. So switching them between them and ensuring they don't interfere with each other. Because this overhead can eat into the performance gains from multi-threading. Fourth is the complexity. Writing and debugging multi-threaded code can be more challenging than single-threaded code, so it requires careful planning and coordination to ensure everything works smoothly. So while multi-threading can offer significant performance advantages, it's not always easy to fully realize those benefits. It requires careful management and consideration of factors like resource sharing, synchronization, overhead, and complexity. So that's it. Moving forward, describe the relevance of scalability to performance. Scalability refers to the ability of a system, network, or business to efficiently handle increasing amounts of work, tasks, or users without compromising performance, reliability, and quality. So it's like the ability of a business to handle a lot more customers without things falling apart. It's about being able to grow smoothly and handle increased demand without causing problems. No. When it comes to performance, scalability is crucial because it ensures that a system can keep running smoothly even when the people or tasks are added. Just like a restaurant needs to be able to serve more customers during peak hours without slowing down, computer systems need to handle more users or tasks without crashing or becoming sluggish. So it means that a system, whether it's a website, a network, or a business, can easily adapt and handle more work or users without slowing down or breaking. So if a system is scalable, it can grow to accommodate more work without sacrificing speed and reliability. This is important because as you know, like let's relate it to business. So as business grow or as more people use a service, or in a website, the demand on computer systems increases. So if those systems can't handle the extra load, performance suffer, and users might experience slowdowns or errors. So all in all, it's all about flexibility and growth. It's the measure of how well a system can handle more work or users as it gets busier. So those are my answers for each question that is presented under the performance enhancement. So thank you for listening and have a great day.